Dear followers, as you have probably noticed, there's a trend that they want to replace teachers with robots, but I'm happy with this because at the university, professor needs to do also research, and to have many lectures, it's really time consuming and energy consuming. So it would be good to send a robot, and then for exam you can come and you can have consultations with your students and everything. So maybe this really be a trend, and we will really see robots as teachers. I don't know how students will behave, if they will respect the authority, and if it's good, if robot will have enough personality to be a role model for students. And I hope they won't all be like robots than themselves. And however, today I'm still doing an old-fashioned, and we have Einstein's field equations, which I already derived on a blackboard. So this is what I would like to explain to you today. I hope you will stay with me until the end, because later follow also videos about hippo. And hippo is many words, it means under actually. And you can have hypothalamus, which is part of the brain, under the thalamus, of course, and also hypochonder, the person who thinks he's ill, but it's really not. So let us move on. So here we have Einstein's field equations, and this lecture is actually a continuation of the lectures about Christoffel symbols, where we derived a vector in component form covariantly. And now, if we derive this vector another time covariantly to another index, which means that A, which is this vector I, semicolon jk, that is double, and we can do also AI kj, a semicolon kj. And you know that partial derivatives x from y, double partial derivative, is the same as if we turn around and we say partial y for x. But in this case, in covariant differentiation, this is not the same. And this means that if we subtract these two, what we call them vectors, derived vectors, we get vector with in subindex L times R superscript L subscript I j k. And this R is actually Riemann curvature tensor. And we have four indices, which doesn't mean it's four-dimensional. It can be four-dimensional, but it actually can be one, two, or whatever dimension you like. It just means it has four dimensions, so it's tensor of the fourth order. And it looks like this: partial k through Christoffel symbol L, I, J, and so on. You can then, maybe later I will zoom in so you will see better and you can watch for yourself. This is this expression. And then Einstein wasn't really alone when he was deriving these equations. Ricci helped him a lot, and also Hilbert, I think, who were very good mathematicians. And Ricci tensor scalar are defined as Rij subscript is Ricci tensor, and is actually a contraction of Riemann tensor from, if we put two the same indexes. Here we see two L's, which then contract. And we get this, and Ricci scalar is defined as metric times Ricci tensor. And then further, Einstein tensor, which is G, capital G with subscript ij. It can be also superscripts or even mixed, one super and one subscript, is then Ricci tensor minus 1/2 of metric times Ricci scalar. And finally, Einstein's field equations are Einstein tensor, which is the same as 8pg, where g is gravitational constant, divided by c, which is the speed of light, to the power of 4, times, this is energy momentum tensor, and it's actually, general relativity is four-dimensional. We have x, y, z, and then c times t, where c is the speed of light and t is time, that we get the same units, and it's four-dimensional space-time, we call it. And this is it. This is what I wanted to show you today. So in the remainder follows what I promised you before, and now I will zoom in so you will maybe see better these equations. Here I think you can see clearly what it's all about. And of course, for more you can ask AI and it will give you an answer. So thank you. This is a hippopotamus that is dancing on a tribal music. He's very happy and also dressed appropriately. And it reminds us of a hippotech, or more words with hippo. You can find it by yourself. And when I go to store, there's usually a dog. Hello! Daj tačko. Come on.